Okay, this next section we're going to talk about the arithmetic sequences. So remember with arithmetic sequences, this is where the sequences are adding or subtracting to get to the next term. And it has to be consistent, it has to be adding the same number each time or subtracting the same number each time. Okay, so if you guys recall, you have your notes page, which you can use on the test and quiz and stuff. That should have all these formulas. So the explicit formula is a sub n equals the common difference times n plus b. The recursive formula is a sub n is equal to a sub n minus 1, which is just the previous term in the sequence, plus the common difference. And then you identify the first term. So with these arithmetic sequences, what it wants us to do is write the formulas for the explicit and the recursive, and then find the 50th term. So to find the 50th term, we always use the explicit formula. That was this one right here. The a sub n is equal to common difference times n plus b, or the zero term. Okay? So first of all, let's look at these sequences. We need to establish two things to come up with the formulas. We needed the common difference and the zero term. So let's find the common difference first. So this is number 5 here. So it goes from negative 13 to 13, and then from 13 to 39, 39 to 65. Each time it is going up by 26. You are adding 26 each time. Okay, so my common difference is going to be 26. So it's adding as we go that way. Now to find the zero term, this would be the term that would come before the first term, and we find it just by going backwards, our common difference. So if I'm going up 26, that means I'd go down 26 from negative 13, which would be negative 39. So now with that information, I have all the information I need to write the explicit formula. Again, when I write the formula, I leave the n's in, and it would just be a sub n is equal to my common difference times n, and then plus or minus my zero term, depending on if it's positive or negative. So I have a sub n. That's always going to be there, and then it's going to equal my common difference, 26 times n, so 26n, and then since it's a negative zero term, it would be minus 39. And that's my explicit formula. Now to set up the recursive formula, it is very, very simple. The beginning part is always the same. It's going to be a sub n is equal to a sub n minus 1. That part's always the same. So a sub n is equal to a sub n minus 1. The other thing that changes is if you are adding or subtracting your common difference. And since we're adding, we're going up by 26, it would be plus 26. Okay, and that's your recursive sequence. Then you need to identify your first term, so I always put like a colon here. And then a sub 1, meaning the first term, is equal to negative 13. And that's your recursive sequence. And then to figure out the 50th term, all we're doing is replacing the n's with 50. So it'd be like a sub 50 is equal to 26 times 50, and then minus 39. Okay, so my times tables are amazing, but not that amazing. So 26 times 50 is 1,300, and then minus 39 is 1261. So the 50th term is going to be 1261. Okay, so if I kept going 50 times on the sequence, it would be at 1261 right there. Yep. Let's look at another example. So over here, well, let's do one. I don't need to do all of these. Let's do one that's subtracting. So let's look at this one. So looking at this one, again, I need to find my common difference and my zero term before I can set up my formulas here. So my common difference is the difference between each term. So 79 goes to 75. Again, if you're not sure how to find the common difference, you can always take the second term, which is 75, and subtract the first term, which is 79, which will give you your common difference. If it's negative, that means you subtract it from the second term, from the first term to the second term. So you went down by 4. So it went down by 4, and if I subtract 4 from 75, I'd get 71. So each time I'm subtracting 4. Okay, so my common difference, my D, is going to be -4 because you're subtracting. And then my 0 term would be the term that would have come before my first term. So these are going down 4. That means if I go backwards, I'm going to go up 4. So up 4 from 79 is going to be 83. So there's your 0 term. Now to set up your formula, it would be A sub n is equal to my common difference, -4n. And then it's a positive 0 term, so I'm going to add 83. And there's my explicit formula. Recursive, again, the beginning part's always the same. A sub n is equal to A sub n minus 1, which means the previous term in the sequence. And then you just add or subtract your common difference. Since this is a going down, subtracting, I'm going to subtract 4. And that's my recursive formula, basically, but I always have to have a starting point, so I always identify my first term. So A sub 1 is going to equal 79. And there's my recursive formula. Okay, then we find the 50th term by using the explicit. So again, you just plug in 50 in for the n, so it'd be A sub 50 is equal to -4 times 50, and then plus 83. So -4 times 50 would be, why am I going to calculate? -200, and then plus 83. So -200 plus 83 is -117. And that would be your 50th term. If you kept going 50 times, you'd end up at -117. And that is basically what you're doing with arithmetic functions, or sequences, sorry. Functions was last year.